Good morning. Today we are going to discuss about EEG or electroencephalograph. In detail, we will be studying the placement of electrodes in EEG and evoked potential, recording of evoked potential, and also after that we will be doing the analysis of EEG signal. Electroencephalograph or EEG, as we know, it is an instrument which is used for recording the electrical activity of the brain. That is, we can place some electrodes on the scalp for taking the measurement, and this method, this EEG signal can be used by the physicians for diagnosing many neurological illnesses and also diseases such as epilepsy, tumor, etc., and also some problems associated with trauma. And also it can be effectively used in operation theaters, that is, while operating, the anesthetized patient's nervous system condition can be observed continuously by taking EEG signal. Now, about the electrodes, we have already discussed about the electrodes which are used in EEG in the previous section, that is part 1 of module 3. Now, these electrodes can be separately placed on the scalp or may be mounted in special bands by mounted using special bands. In either case, we can use some electrode jelly or paste which can increase the electrical conductivity, and also we can use, in some cases we can use some needle electrodes also. Now, the EEG recording is done in two ways, that is monopolar recording and bipolar recording. What is a monopolar recording? That is, if the EEG signal is measured, that is, if the voltage difference between an active electrode on the scalp with respect to a reference electrode on the earlobe is measured, then it is called a monopolar recording. That is, while measuring or while taking the EEG signal, if we are using two electrodes among which one is the active electrode on the scalp and the other is the reference electrode, then it is called a monopolar recording. But in bipolar recording, we will be using two electrodes placed on the scalp itself. In the monopole recording, one electrode will be placed on the scalp and the other will be the reference electrode which is placed on the earlobe. In bipolar, we will be using two electrodes, both will be placed on the scalp only. Now we are going to discuss about the placement of electrodes in EEG. Here you can see the figure. So here it is the left side of the head. This is a 10 by 20 system. The 10 by 20 system is the standard method adopted by the American EEG Society for placing the electrodes. That is, the electrodes are arranged on the scalp. There will be some 21 electrode locations. These are the electrode locations. You can see FP1, F3, F2, C, P3, etc. And this pattern of electrodes on the head and the channels they are connected to is called as the montage, or this pattern of electrodes along with the channels which are used for connection together known as the montage. The montage is always symmetrical. As you can see, the montage is always symmetrical on both sides. It is symmetrical. Now, the electrodes are placed by measuring the Nash-Inian distance. Here it is, this is the distance from the distance from this point to the Inian point. This is the total distance, and first of all this distance is measured, and after that the electrodes are placed at 10% of the distance. One electrode will be placed. After that 20% of the distance another electrode will be placed. After that 20%, then 20%, and after that 10%. Like this the electrodes will be placed. Now these electrodes are identified according to their position. You can see the naming of the electrodes, that is the F F denotes F3, F2, that F denotes the frontal area. Then FP denotes the frontal polar area. And after C is denoted as the central is denoted by C, and the parietal is denoted by P, and the temporal is denoted by T, like that. All these letters have a suffix, some numbers as a suffix. You can see that the odd numbers refers to the electrodes on the left side of the head, and the even numbers represents those on the right side of the head. Z denotes, you can see ZZ. This Z denotes the midline electrodes. Okay, this is the method of naming of the electrodes, and you can see here is the left side of the head, and the top of the head, you can see this is the representation for the top view. Now this is the 10-20 of electrodes. Now in this there will be an electrode which is marked as isoground, which is placed at a relatively neutral area on the head, usually the midline of the forehead. So this was the 10/20 system of placement of electrodes. Now this placement of this is the standard method. Recently another method is introduced, that is the electrodes are placed at 5% distance along the cranium. This is just for introduction. I am denoting this method. This is electrodes are called closely spaced electrodes. Now for exams you have to write only the standard method, that is this 10/20 system. Just to know, I have discussed about this closely spaced method of placing electrodes, and this 5% at a 5% distance electrode will be, these are all electrodes will be placed at a 5% distance. So that was all about the placement of electrons in EEG. Next we are going to discuss about the evoked potential. Now what is an evoked potential? While taking the EEG measurement, we can use evoked potentials also for better measurement. That is, what is an evoked potential? That is, we will be applying an external stimulus to the sensory area of the brain, and it responds, the brain responds by producing an electrical potential, and this potential is known as evoked potential. That is, for getting electrical activities or for taking electrical measurements, we will be giving some external stimulus to the brain, and the brain will react to that stimulus, and this electrical potential, that reaction of the brain, that is known as the evoked potential. Okay, now electrical stimulus we will be giving mainly evoked potential for we will be using some auditory responses, or we can give some visual evoked responses. The most frequently used evoked potential for clinical testing include that auditory, visual, and also somatosensory, that is will be using some peripheral nerves, be giving some electrical signals to the peripheral nerves. Now usually the evoked potentials are superimposed with the electroencephalograph. So we have to remove these EEG signals. So the method is that we can take multiple measurements, and after that we can average the signals, so that we can, by averaging, we can remove the EEG signals. We will be taking multiple trials, and after that averaging is done to remove the EEG signals. The evoked potentials are always superimposed with the EEG signals. So, to get the evoked potentials we have to remove the EEG signals. How can we remove the EEG signals? We can take multiple trials and after that we can average it. By averaging we can remove the EEG signal, because the EEG signals will not be synchronized with the stimulus. So, they will be different. There will be difference. So, while averaging it gets cancelled. Here is the example. So, first one is a raw EEG signal, the second one is the averaging of 8 responses, and third one is averaging of 64 responses. Next we are going to discuss about the analysis of EEG signal. Now from the EEG signals we can take the frequency and amplitude information which can be used by the physician for doing the diagnosis. First of all we will see how the frequency analysis is done. The waveform is the waveform is broken into different frequency components. How can we do that? We can apply the fast Fourier transform f of t to the waveform. Applying f of t divides the signal into its basic frequency components. That is, fast Fourier transform of the digitized EEG waveform is a mathematical transformation of the complex waveform into simpler, more uniform waveform. By applying f of t we can divide the complex EEG signal into simpler waveform. These simplified waveforms are known as spectrum. Now this spectrum is separated into frequency bands. After getting the spectrum, it is separated into frequency bands at different intervals. Separated into frequency bands at intervals of 0.5 Hz. And from these frequency bands, specific physiologic and pathologic conditions can be diagnosed by the physician. So that was about the frequency analysis. Now we will discuss the amplitude analysis. Now changes in EEG amplitude can indicate clinical changes. That is, the amplitude changes will give the power variations in the frequency spectrum. Squaring of the amplitude will give the relative power, and from this relative power we can make many clinical diagnoses. Now this there are mainly two methods of representing or displaying the formats. That is, for visually enhancing the computer processed information, we can use two display formats to get the amplitude analysis. First one is the compressed spectral array or CSA, and the second one is the dot density modulated spectral array. Now what is this compressed spectral array? So here is the example for compressed spectral array. This figure, the first figure is an example of ordinary EEG signal. In the second figure, it is divided into its frequency component. That is, this is the spectra. That is, here you can see the signal is divided into its frequency components. Depending upon the frequency, different frequency components are detected, and you can see this is the delta frequency, this is the theta frequency, and this is the alpha frequency. So second figure gives the frequency components, and this is the smoothened waveform of the EEG signal. Now this is the compressed spectral array. What is the CSA? In this format, the series of computer smoothened spectral arrays are stacked vertically. So these smoothened arrays are stacked vertically. stacked vertically, usually at 2-second intervals, with the most recent EEG, most recently taken EEG even at the bottom, and the oldest EEG will appear at the top. With this method, it is easy to pick up changes in frequency and amplitude of each sample over longer period of time. That is, different EEG signals are stacked one over the other. By stacking, it will becomes very easy to pick up the changes in the frequency and amplitude. And this is the method of compressed spectral array, CSA. Now, the next method is the dot density modulated spectrum array, and this method this is also a method of displaying the power spectra. This format displays a power spectrum as a line of variable intensities. This power spectrum is displayed as a line of variable intensities, same as that of CSA. Successive epochs are stacked vertically one over the other. In this format, areas of greatest density represent frequencies which make the greatest contribution to the EEG power spectra. This can be analyzed that areas are taken for analysis. Now, an advantage of DSA format over the CSA is that no data is hidden by the peaks. So that was about the analysis of EEG signal. So we have all discussed about what is an EEG signal, after that placement of electrodes, and after that we have discussed about the analysis of EEG signal. Okay, thank you.